All right, we're running an example problem on the motion of the center of mass. And exactly which problem it is in the practice and exactly which chapter's practice will depend on which school this is at. But here's the problem that we'll be doing regardless. A 1,200 kilogram station wagon is moving along a straight highway at 12 meters per second. Another car with mass 1,800 kilograms and speed 20 meters per second, that should be 20.0 I'm noticing, has a center of mass 40 meters ahead of the center of mass of the station wagon. Part A, find the position of the center of mass. Part B, find the magnitude of the total momentum. And part C, find the speed of the center of mass. So first things first, I need to get a couple of cars drawn out. Let's see. They're going to be goofy looking. And this one is 12.0 meters per second. This one is 20.0 meters per second. We presume they're in the same direction because they're on a highway. One is behind the other. It sort of implies one's following the other on a highway, not that they're headed towards each other. So we're going with that. All right, 1,200 kg for the station wagon, 1,800 kg for the one ahead. And the distance between their centers of mass, 40.0 meters. All right, part A, find XCM. Okay, so here's what we get for a picture. All right, we aren't concerned with the velocities at all at this point. We're just worried about m1x1 plus m2x2 all over m1 plus m2. But in order to do this, we need to have an origin for our coordinate system. For convenience, I'm putting the origin of the coordinate system at the station wagon. So that means I'm going to get 1,200 kilograms times 0 meters plus 1,800 kilograms times 40 meters all over 1,200 kg plus 1,800 kg. All right. So let's see, 18 times 2 is 36, times 2 again is 72. So this is 72 followed by 3 zeros, divided by 3,000 kilograms. And this is a kilogram meter on top. Kilogram cancels. The 3 zeros cancel. 72 divided by 3 is 24, so 24.0 meters is the center of mass relative to the 0 point I've set. You can set the 0 point anywhere you want. It will change the exact value, but the location will still be the same in the sense that if we drew it in the same picture, if I drew my coordinate system and my center of mass location and you drew yours, we'd actually agree on where the center of mass is, even though we're getting different numeric answers. So keep that in mind. B is find momentum total. Well, that's really easy. That's just m1v1 plus m2v2. So we have 1,200 kilograms times 12.0 meters per second plus 1,800 kilograms times 20.0 meters per second. Let's see, 12 times 12 is 144. This gets 2 zeros after it. So 14,400 kilogram meters per second plus 18 times 2 is 36. So 3 zeros, kilogram meters per second. Sorry about the noise. Let's see, 14 and 36 adds up to 50 plus another 400, so 50,400 kilogram meters per second will give us our momentum total. It was earlier than I expected the beep. So my apologies, I thought I'd finish before it got to this point. All right, but the sound is past. Last part is asking for VCM. Well, we kind of went over this, and VCM is a sum of the mass times the velocity divided by a sum over the masses. But that's the same thing as the total momentum over the total mass. So we've already got the total momentum. 50,400 kilogram meters per second. And now we've got 3,000 kilograms is the total mass, 1,800 plus 1,200. So let's see, we can cancel a couple of the zeros here. We can actually take another zero out. It would be 50.4 divided by 3. The kilogram cancels. Alright, so 3 times 16 is 48, which is a remainder of 2.4, and that goes in 0.8 times. So 16.8 meters per second. Let me explain a little bit. 2.4. Well, if it was 24, 8 times 3 is 24, so it's going to be 1/10 of 8, which is how I got the 0.8. All right, so that was a pretty easy one. A lot of the center of mass problems and a lot of the acceleration of the center of mass problems tend to be kind of similar. They're not usually super challenging on their own. They can have additional parts that push it. But that's a fairly typical problem for finding the motion of the center of mass. All right, so we're going to stop there and see you in the next example video, or next video overall.